Okay, so what we've done so far is, on the quadratics unit is we have learned, so this is your formula sheet, and so you're allowed this on your final exam and everything else. On the formula sheet here, we have quadratic formula, but there's three different ways of writing it. Now the preferred way is the standard form. Okay, and that's where y is equal to a, x minus h, and k, where h and k is your vertex. That's the most important point on a quadratic, right there, or right there, or right there, or could be upside down too, to be the top. So this is referred to as a minimum, and then if it's upside down, it'll be a maximum. Last class, we introduced a little bit, this is the preferred format, and we can do a whole bunch of stuff. We're going to be reviewing that. But there's another format where it's in ax squared plus bx plus c, and that's the preferred calculator format. And so if you have a calculator, it likes giving it to you in this format. And so we're going to have to know how to go from this format to that format, and that format to this format, basically interchange. And the thing with the general format is the a value is the same. Okay, so we can actually use that. So if our calculator figures out the quadratic equation, gives us the a, we can use that a for here. And if we merely graph it, we could figure out, when we graph it, we can figure out what that point is on the calculator, and then we know what the h and k are. And we're gonna be reviewing that with the calculator in a little bit. I've got a little bit of an interesting way of doing that. That's I call it my Angry Bird sheet, and we'll be seeing lots of Angry Birds here a little bit later. What I do want to show you though this morning, is the third format, which is transformational format. Now, this is a format that's preferred by a lot of math teachers. I'm not one of them. I don't really like this transformational form. I know why they do it, and it kind of makes sense, but I'm not a big fan of this thing. As a matter of fact, if you hear me, I'm on tape here, so I have to kind of be careful what I say, but I've got a nickname for this transformational form. I call it useless format, because basically we don't need it, but the reason they would give you this equation in this particular format is because in general form and standard form, you can pull out your calculator and you can figure out the answer just by hitting the y equals button and then typing it in, and it'll graph it for you, and it'll give you all your answers. Well, in transformational form, if you're a math teacher, you don't want your calculator doing all the work. You want to be able to understand, have your students understand what you're doing. And so in this particular format, your calculator, you can't punch it in your calculator, and so you can't get that answer right away. So we're going to learn how to, if you're given in transformational format, how to put it into standard format, and likewise, if it's in standard format, how to put it in transformational format. But basically, today is kind of the only day that we're going to be doing that, learning how basically to get it out of useless format and put it into something normal and standard that everyone else uses. Does that make sense? So if we can punch it into a calculator, then we can get a whole bunch of answers. But this part, we have to convert it a little bit until we get it into the right format. Okay? So let's go into a little bit of what transformational format is. Transformational form is in the form of 1 over a. Okay? Now, that a is the same a, okay, that we were talking about before. That's your reflection, that's your up-down thing, and that's your size factor, skinny fat factor. Okay? And then we have y minus k. That k is the same k that we learned in standard format. Okay? Is equal to x minus h all squared. So this is actually an easy format to know, especially if you have your formula sheet. You can easily transform this into standard format. So I'm going to write, this is transformational form. I'm going to write standard form, or this, I'm going to abbreviate the STF for transformational form, so I don't have to write that out all the time. And SF is standard form, and then GF is general form, but we're not going to worry about general today. Standard form is y is equal to a, x minus h, all squared, plus k. So this h, this k, and this a are the same h, k, and a. Okay? And so all we're going to do is we're going to take the a and put it in front, take the k, put it over there, take the h and put it over there. Now there's a couple tricks here that you will have to know, and you already know them. what's the kind of the gotcha here with the A, H, and K for standard form? Well, when you have your H, when you pull it out into your vertex, what do you have to do with the H number? Because it's in brackets, you pull it out and you have to flip it. Okay? So let's try that just as a reminder. Here, example. This is in standard form. Y is equal to 6x minus 2. I'm just making these numbers up at random. Okay? So the vertex, the most important point on a graph, is going to be 2 and 3. 2 and 3. And because this is in brackets, it was actually negative 2. So it would be, well, it's positive 2 because I have to flip it. It's in brackets. And then the A is equal to 6. Okay? The H is equal to positive 2. And the K is equal to 3 if you wanted to do it that way. And then we would start off at 2, 3, so I'd go over 2 and up 3, and then from that dot I go over 1, and I'd count up 6 dots because my stretch factor is 6. This is a 6, which makes it super skinny, 6 times skinnier than normal, so it's a really thin graph. Okay, that's how we do standard. That's what we've done in the past, and we'll do a few more again today, just to get used to that. I'm going to give you an example now of the transformational form. Okay, so here's just a simple example, 1 over 3, and again, I'm making these numbers up, minus 2 is equal to x plus 4 all squared. And I want to know exactly the same thing. Okay, I want to know what's the vertex. That's the most important point in any quadratic equation is the vertex. Tell me what the vertex is. Well, if you notice, this x is in brackets with a square. That's the same x in brackets with a square. And so the x is always the first coordinate. It's always x, y. So the first coordinate would be 4. And since this is plus 4, because I'm pulling it out of brackets, it's minus 4. So that's the same. So the x doesn't change for standard form or transformation form. It's whatever it is, you pull it out. Now when we go over to the y, well, the y is with the y. And this is kind of makes sense where x is with x and y is with y. But the y value is going to be that number right there. But you notice it's in brackets. So when I pull it out of brackets, it's going to go over here and it's going to be positive 2. It is negative 2 in brackets, but when I pull it out, there's another case. It's the same case as this. When I pull it out of brackets in an equation, these are brackets here too, but that's not an equation. That's just a point. So this is a coordinate point. And some people, I can't do these curly braces very well. Well, that's a nice one. So some people actually write their coordinate values in curly braces because they want to realize that they're not actually brackets. They're braces instead. And so I don't do that because it takes me too long to do the fancy stuff. So, but just realize this is a point. It's got a comma in between. And so what do? We flipped it and we flipped it because there's 2 brackets. Guess what the a value is? Well, it's the bottom number, right? Here's the fat skinny factor, right? The a. It's 1 over a, so a is equal to 3. And so since it's positive, that means if I were to draw this graph, I would go, the vertex is backwards 4, so backwards 4, up 2. So let's actually do it. 1, 2, 3, 4, up 2, 1, 2. There's my most important point. There's my vertex, big dot. And I'm going to go over 1 and up 1, 2, 3. 1, 2, 3. It's going to be 3 times skinnier, over 1, up 1, 2, 3 times skinnier. And there we go. Just like that. Okay, so it's the same, it's different, it's the same thing, but it's different. Okay? And so what I would say is, well, we know what the vertex is. We know what the vertical stretch factor, the a value is. Okay? Now, some people, instead of calling the a, they actually call it the vertical stretch factor, the VS factor. And so the VS factor is 3. And then some people I mentioned too, there's a prescription here. It's not prescription. This is reflection. There is none. So there is no reflection. So actually, I wouldn't even put that in. So reflection is none, which means, is it upside down or not? No, it's not. It's pointing up. So the regular standard U or quadratic or parabola is pointing up. So there's reflection. There's no reflection. What would the horizontal translation be and the vertical translation? Well, the horizontal and the vertical translation are simply the x, the horizontal, the horizon, or the vertical takeoff, the VT is up and down. So the horizontal translation is the vertex, -4. And the vertical translation is +2. So I shifted this over 4 units to the left, and I shifted this up 2 units to the right, or to the, well, up. Okay, so these are all terminologies. All you have to do is find the vertex and find the vertical stretch factor, and you're done the question. It's just a matter of, okay, now what are they asking now? Vertical stretch, that's A. Reflection, that's A. Horizontal translation, that's the x of the vertex. Vertical translation, that's the y of the vertex. Okay? And that's it. Okay? Oh, we did do one more thing. So we did the axis of symmetry. X is -4. Okay, again, this is the vertex. So once you have the vertex, it's kind of game over. And is there a range here? Call the range. And we said, well, this one here, the lowest number possible is going to be 1, 2, 2. So the minimum, we call it the minimum, equals 2. Because the lowest number possible is a U-graph. And because it's a U pointing up, it's the lowest. If it's a U pointing down, then it'll be the maximum instead of the minimum. So the minimum is going to be 2. And so that's kind of that's what I refer to as my range. So some people actually say, well, y has to be bigger than or equal to 2. Okay? Now, if you put minimum equals 2, that's fine. This is the fancy way of doing it in math. And the really fancy way, it would be to say y bar y funky e funky er, okay, comma, y greater than or equal to 2, and put that into curly brace, and put that into curly brace, and that's the fancy way of writing it in mathese. Okay, if you're speaking, mathematical, y, we're talking range, and so this is included. The y is a set of real numbers, okay, which means that they're not imaginary, they're not some fictitious number that you can't think of, okay, and it has to be greater than or equal to 2. So I prefer this. Minimum is equal to 2. That tells you it's a U going up, and the lowest value is 2. Okay, so for the little worksheet I'm going to give you here shortly, either one is acceptable. I would probably stick to that because it's nice and simple, as opposed to all the fancy math stuff. Okay, so let's try another example of converting. So basically, if we were to go from transformational form to standard form, how would we do that? Well, here's the transformational form. Ready? 2/3, again, another example. 2/3 y plus 2 is equal to x minus 3 all squared. There's the question. Convert this into standard form. And so here's standard form. Y is equal to blank. And I like putting it in 3 blanks. You got 3 blanks, fill in the blanks. Well, let's do the easy blanks first. The x with the x. So, for standard form, you got your h in your k, and you got your h in your k. And if in doubt, you can look on your formula sheet here. It tells you, here's the formulas, and you're allowed your formula sheet. So here's your standard form. There's your blank, blank. All you have to do is refer down here, and here's your blank, and here is your blank. Now, I've set this thing up a little bit differently for the a value, but let's do the easy stuff. X minus 3 squared, guess what it's down here? It actually is the same, x squared. The x part doesn't change at all. The y plus 2 is on the wrong side, so when I move it to the other side, this plus 2 here, it comes out of brackets. And over here, there's no brackets, so it's only going to be minus 2 over there. And if that's the case, when I write the vertex, the most important point on this UE graph, it's going to be +3 and -2. So you can come up with a vertex in one of 2 ways. You can convert to standard form and do the normal, Or you can say, well, listen, the x goes with the x and the y goes with the y, and since they're both in brackets, then I can pull it out and I can just say, well, the vertex is, well, positive 3 and negative 2. Right? So I flip that one and I flip that one because they're both in brackets. So however you want to get that vertex that way or the way that we've been doing it in the past, it's up to you. The only thing we have to figure out now is the A, and the A is, well, it's the vertical stretch factor, it's up-down factor, and this one, the A is on the bottom, right? And this one, the A is on the top. So I'm going to write A over 1, and this is 1 over A. What did we do with the A? Well, we inverted it. We flipped it upside down. So it's 1 over A here in the useless form, the transformational format. So how do you get it into the normal format, standard format? Well, you flip it top for bottom. Okay? So what we're doing is we're moving it to the other side and we're flipping it top for bottom. So top for bottom, 2/3, when we write it into normal standard format and get it out of the useless format, then what we're going to do is we're going to flip it here. And so instead of 2 over 3, we're going to have merely 3 over 2. And I'm done. So the A value is 3 over 2. Is there a reflection? No. Okay? What's the vertical translation? Negative 2. It's always the Y. What's the horizontal translation? It's the plus 3. It's always the X. Okay? Is this opening up or opening down? Opening up, because this is positive. Is this a fat guy or a skinny guy? Well, 3 over 2 is the same thing as 1.5. So it's normal size a little bit skinnier because it's bigger than 1. If it's a fraction less than 1, so like 0.5 or 0.2, the smaller the dress size, the wider it becomes. So this one's a little bit skinnier, but not too much. Okay, so you go over 1, up 1.5. What else do we have? The axis of symmetry. Axis is spelled A-I-X. So X is. What is X? It's plus 3. So it's positive 3. So there's a line going straight down through the 3 number. That's our mirror image. What else we got? The range. Well, since this is opening up, we have a minimum. And the minimum value for Y is negative 2. What else do we got? We got vertical translation. Just kind of go through the whole thing. If you really want to write the old way, it's always kind of the same thing. And again, this is on your formula sheet, the standard, and it's got to be greater than or equal to negative 2, and then the fancy braces. Again, you can write the range like that, kind of all in weird gobbledygook, or you can write in the minimum is negative 2. And that's it. Okay. Now, it's pretty simple. They invented transformational form so they can give you a whole bunch of math questions in the math textbook, and you can't plug them into your calculator easily. But if you merely flip the A and move the Y over, you're done, and you can put it into Y equals anyways. So all we did is you leave the X, okay, you flip the Y, bring it over, and you invert the A, you bring it over, and you're done. Now there is one, not exception, but it's one little trick you have to watch, and that's sometimes the Y value doesn't appear to be there. Okay, so let me go through that example. And here's an example. Here's the last example I'll do, and then I'll get you trying it out on the I've got a transformational chart, and we'll try it. Example. Let's see here. There. Y minus 2 is equal to x plus 4 all squared. So I'm missing some numbers here. So you have to kind of know your defaults still. That's in useless format, transformational form. We want it in standard form, which is y is equal to blank and blank, 3 blanks. 1, 2, 3. Okay? Well, the easy thing is x plus 4 is still x plus 4. That didn't change in transformational standard form. So do it, and you at least get 1 point. The A value, what's the A value? There is no A value. And there's no Y value. So let's do the Y value next. The Y value, would be minus 2 over here. And since it's not in brackets, I don't have to flip it. So you'd think it'd be minus 2 on this side, right? But that's where the trick is. Okay? The trick is, what is the number in front? What is the A value? Because you have to come back to the A value. Well, the A value is 1. And so if I put a 1 in front of here, well, it's actually a 1 in front of a bracket. But because the 1, the A value, is the default value for A, I didn't write it in. And so I didn't have so this is still 1 over 1. That doesn't change. The A value doesn't change because 1 flipped is still 1. But because this is 1, I didn't write it in brackets. And if I didn't write it in brackets, when I move it to the other side, I have to be careful that, that I still have to flip it. Even though this isn't in brackets, I didn't put the brackets in because of the, so it should be in brackets still. And so the bracket rule still applies. So this is negative 2 on this side. But when I move it to the other side, what is it going to be? It's going to be plus 2. Okay, so the vertex then would be negative 4 and 2. And you can flip this one and flip this one. But just realize that sometimes the question, if the A value doesn't appear to be there, it's 1, well then the brackets may not appear to be there. And so just remember to flip it. If it's in transformational form, you have to flip the Y and the X. If it's in standard form, you only have to flip the one with the brackets. Okay, so a little bit of a trick, but not too much. Again, if you want the X is the axis of symmetry, that's negative 4. We want the minimum, because it's opening up, would be equal to 2. That's the range. The horizontal translation, well, that's negative 4. The vertical translation, what's that? Well, it's 2. So this is basically the X. This is the Y of the vertex. Once you get the vertex, you got it all. Oh, the stretch factor, A, it's 1. So it's normal size. Is it opening up or opening down? Well, it is opening up. How do I know? Because it's positive 1. If it was negative 1, then it'd be opening down. Okay? So that's kind of the only trick I think I can probably give you for transformational form. But what we're going to do here is I've got a little chart here, and I call it my transformational chart. Let's see if we can see this. So I give you the standard form. Okay, the most important part is your vertex. So the vertex here will be, you flip the 1 inside the brackets, so it's 1. And then you take the other number, it's 1, 2. Okay, so what's the transformation? Well, the transformation would be your horizontal translation. Did we move it over on the X? Yes. That's equal to 1. Did we move it up and down on the Y? Yes. The vertical translation is 2. Is it opening up or is it opening down? Well, that's the A value. So it's opening up. So is there a reflection? No. There's only an Rx. So we don't say Rx equals none or anything. If it says Rx, like this one does, that means that the A value is negative. That means it's opening down. So this particular question number 3, whatever it is, it's opening down. Okay? This one, there's no Rx, but there is a vertical stretch factor. The vertical stretch factor there is the VS. The VS, or the A, is 3. And so those are the things, that's how we've manipulated this regular quadratic right at the origin, right at 0, 0. We moved it over 1, up 2, and we vertical stretched it. We skinnied it up by 3, and there you go. That's what you have. Now, how do you write this in the useless format? Okay, transformational format? Well, the A value would be 1 over A. The Y value would be Y. And then the vertical, the Y is over here. So it's plus 2. So it's minus 2 inside the bracket. So I went from outside a bracket, and I had to put it inside a bracket, so I have to flip it. This one is going to be bracket squared in X, and take the X number and flip it as well, X minus 1. So you see here, the X minus 1 is the same, X minus 1 is the same. Okay, so there's transformational form for it. Now you have to be kind of careful here with the room, so you have to kind of write small. And what I should do is I should maybe make the range here a little bit smaller. Okay, now the range, we can say the minimum is 2. Keep it simple. Okay, now technically I'd have to write it with the funky brackets and all that stuff, but we're just going to keep it simple for now. And then next class we'll learn about the mapping rule 2. And we're almost finished this quadratic thing because we're going through this like really quickly, which is good, right? We did the hard stuff earlier on this year. Okay, so I'm going to give you the sheet here. I'm going to go around and check it with you and help it with you. But basically, we want to go from standard form to transformation form, back, and then all you're just writing out is this is the x of the vertex, this is the y of the vertex, this is the a, and we already did this. We just put down a, h, and k. Well, they're just changing the names to ht and vt and vs, and then possibly an rx if it's upside down. Okay, go from that.